So today we're going to be talking about ordering real numbers, putting real numbers in order from greatest to least, least to greatest. You might think of it as biggest to smallest, smallest to biggest. But sometimes, just like last year, remember last year when we put numbers in order from greatest to least and least to greatest, they just threw all kinds of numbers at you. They might have given you a fraction, a decimal, and a percent, and they said, here, put these in order, right? It's going to be like that again this year, but since we're in the real number system, we're adding in the square roots or pi, some of those irrational numbers. But the same principle applies. When you're trying to compare something, you need them to be all the same. Doesn't it make it easier to compare if everything was decimals or everything was fractions with common denominators? It makes things a lot easier and simpler. So something that we are going to do when we are going to compare real numbers is we're going to put them all in the same form. So that's the first thing I want to write down is my little reminder that says when comparing real numbers, put them in the same form. And that form could be all decimals. It could be all fractions with common denominators. Oops, misspelled it. I could even put them in all percents if I wanted to. As long as all of them are the same form. I'm going to tell you decimals is the easiest one to do. Because even if I want to put it as a fraction, I got to first put it as a fraction, then a common denominator. That's 2 steps. If I want to change everything to a percent, most of the time I would either have to change it to a fraction over 100 or a decimal and then make it into a percent. Again, 2 steps. But if we put everything in decimal form, it's just a 1-step deal. And it makes it a lot easier to compare our numbers. For our first example, I'm going to give you a set of numbers, and I want to put them in descending order. I want to put them in descending order. Here's your set of numbers. My first number is going to be 5.5. Then square root of 26. The next number in the set is going to be 5.8 or 5 8/10. And the last number in this set is 31 over 5. Now, that's kind of hard to tell which one's bigger, which one's smaller. They all look different. It's kind of like comparing apples and oranges. I need to get them all the same. But I also need to know, is this going least to greatest or greatest to least? What does descending order mean? Least to greatest, so it's going from small getting bigger? What do you think? Greatest to least, so going down. Descending, if something is descending, that is a key word that it's going down. Descending means down. So I need to put a little note so my brain knows that I am going from greatest to least. And I'm going to do that like this. Greatest to least. That's so my brain knows that I'm looking for my biggest number first, going all the way down to my smallest. We don't want to do all this great work and then put them in the wrong order. We don't want to put them backwards. But right now they're all different, so let's put them all in decimals. So underneath each one of these, I'm going to write its decimal equivalent. So then I have a row of decimals to compare. So what is 5.5 as a decimal? 5.5. Square root of 26. Is that a perfect square? No, so I'm going to have to estimate it, which means I need to go do some side work. I'm not going to do it right here because that's where my decimal goes. I'm going to go off to the side and do some scratch work, or I call it side work. Square root of 26 falls between what two perfect squares? 25 and 36. If I take the square root, that means it's between 5 and 6. Is it closer to 5 or is it closer to 6? 5, and it's really, really close, right? One step away. One step away. So what kind of estimate do we want to give this? Okay, 5.1. Could I have said 5.2? Yeah, I do think 5.1 is probably a better choice because how close it is. It's only just super, super close. The third number. Oh, yay, it's already a decimal. Let's just bring it down so that way they're all in line. Now 31 over 5. I've got to do some side work again. How do I change a fraction into a decimal? What? Top in, bottom out. That's a division problem. 31 divided by 5. 31 divided by 5. Top in, bottom out. 5 goes into 31 how many times? 6 times. 5 times 6 is 30. 1. Bring my decimal 0, decimal up, 0 down. 5 goes into 10 how many times? 2. And it goes in there evenly. So this is 6.2. All right, now am I looking for my biggest or my smallest number first? Biggest. So out of my decimals, who's the winner? 6.2, so that one is in first place. That's the winner. Who's going to come in second place? Who's next biggest? All right, there's second place. What about third place? Third place. And last is fourth place. Now, I know we can tell what order they are, but this is not my final answer. If this was a test question, my answers are not going to be 3, 4, 2, 1. They're not even going to be all the decimals. My answer choices would be from these numbers, right? The original numbers. So for your final answer, you must have it in the original form. Notice, my work is very organized. If I went and did all my scratch work and my decimals over here, couldn't I easily mix up which decimal goes with which number? So by doing this, I know exactly who goes with where. So, first place, what was its original form? All right, write it down, 31 over 5. Second place, what's its original form? 5.8. Third place, you got it, 5 1/2. And then last place, square root of 26. Final answer, put a box around it. And because this is our notes, if we ever need to go back and look at something, let's remind ourselves that final answer must be in original form. Just so we know if we ever had to go back and look at it, oh yeah, our final answer must be in the original form. Starting to come back a little bit when we did this from last year. Now we just kind of threw in some square roots. I could also throw in pi. What decimal would pi be? 3.14. If you don't know that, maybe make yourself a little note. Pi is about 3.14. But we're not going to be using that this year. All right, I want to do one more example, but I don't have enough room here. So I am going to turn my paper over. Can I turn the page? Yeah. Okay. I want to do one more example that brings in some negatives. So here's my next example. And this time, I want to put the numbers in ascending order. And does ascending mean to go up or down? It means to go up. All right, you ready for your numbers? First number in the data set is negative 28 over 3. Man, starting off with the fractions. Next number is a positive 7.9. Next number, negative 8 and 6/7. And the last number is going to be negative square root of 64. All right, are they all the same form? I got some fractions, some decimals, some square roots. They're all different. So I'm going to need to make them in the same form, but I need to know I'm going up, ascending. Is that least to greatest or greatest to least? All right, make your brain note. Least to greatest. I find when you make this really big and you make it stand out, it helps your brain remember which order you're putting these in. So now we got to give them their decimal equivalents. Negative 28 over 3. It's a fraction. What do I have to do? Top in, bottom out, divide. Side work. 28 divided by 3. 3 goes into 28. 3 times 8 is 24. 3 times 9, 27. So that's as big as we can go without going over. So 9 times 3 is 27. Remainder 1. How do I keep going? Decimal 0. Decimal up. 0 down. Now 3 goes into 10. 3 times, because 3 times 3 is 9. I get a remainder of 1. What's going to happen? It's a repeater. And it's negative. So my decimal is negative 9.3 repeating. The second number is already a decimal. I'm just going to rewrite it. 7.9. The third number is a mixed number. But I already know what the whole number is going to be. What's the whole number here? Negative 8. So I can go ahead and start negative 8 point something. To figure out what that something is, I can just divide 6 divided by 7. 6 divided by 7 7, does it go into 6? Nope. Decimal 0, bring my decimal up. 7 goes into 60 how many times? 7 times what gets me as close to 60? 8. Because 7 times 8 is 56. I have a remainder of 4. Well, let's see if we can go again. Bring another 0. 7 goes into 40. 5 times. 7 times 5 is 35. Remainder 5. Now, if I just went ahead and stopped here, if I said negative 8.85, is that enough information that I can kind of see where it's going to go? Do I need to keep dividing it out? No, because I didn't have any other 8.8 somethings. So that's a good stopping point. I'm okay with that. Now this one. If I know the square root of 64 is 8, but I have a negative out in front, that becomes negative 8. Or if you want to put a decimal, 8.0. Almost done. Now, am I looking for the big or the small number?
Small.
The small number. So here I have a mixture of negatives and positives. What's going to come first for small numbers, negatives or positives? Negatives. So I could even cover up this positive number if I wanted to right now, because I don't need to look at it. I need to figure out which of these negative numbers has the smallest value. And what did we say about negatives? The bigger the number, the smaller the value. The bigger the number, the smaller the value. So if I look at these digits, 9.3, 8.85, 8.0, which one looks kind of bigger? The 9.3, but because that's negative, the bigger the negative, the smaller the value. Since I'm looking for my little one, negative 9.3 is first place. It's the smallest valued negative. Now out of these, which one's going to be my next smallest value? 8.85. The bigger the negative, the smaller the value. Which would make negative 8.0 in third place. Then I know my positive number, the only positive number I have, has to be the biggest. Questions on that with the negatives? The negatives kind of get a little tricky sometimes. All right, are we ready for final answer? Okay, first place, what's its final answer? Negative 28 over 3. Second place. Negative 8 and 6/7. Third place. Negative square root of 64. Don't forget the negative. And then last place is 7.9. Final answer, put a box around it. Look at all that beautiful work. Beautiful notes.